but more puzzling to him was the ability of capacitors to pass AC, and he was wondering, how can this be? Well, this is my representation of a capacitor that is not charged. And if we were to add a battery to it, immediately electrons would start the flow, and notice at each side of the capacitor which way they're flowing. And this will continue until the capacitor is charged up to, in this case, the level of the battery, and then the current will stop. Let's take a look at this a couple of times. At this time, the capacitor is charged, and you could consider it now that it is blocking DC, but all that means is the capacitor is charged up to the DC value of where it is in the circuit. Now, if I would have reversed the battery, of course we would end up with this, a fully charged capacitor with the opposite polarity. Now let's take a look at AC, and of course it's a good idea to understand what alternating current is. It means that the current will move in one direction and then reverse direction and then reverse back again. Here we have reached the most positive part of the alternating current, and now it's going to start going back down and go past 0 and then continue on until it reaches maximum negative voltage, and then it's going to go back in the other direction towards 0, and when this is complete, this is one cycle. Let's watch this one cycle a few times. Now, of course, this is only one cycle. It actually continues going up and down. And here I'm showing 3 cycles, but it just continues this changing from positive to negative, the definition of alternating current. Now here is a capacitor hooked up to an AC source, and when it's positive on the left, it'll charge the capacitor like this, and when it's positive on the right, it'll charge the capacitor this way. But notice, as this alternating current goes back and forth, the electrons, shown by the arrows, keeps flipping back and forth. Also notice that there are no electrons that travel between the plates, which was also true with the DC battery. No electrons travel between the 2 plates. It is the charging and discharging of the plates that is causing the current flow, and because this is alternating current, it is a continuous process. Now, all that we can really see in the circuit is a capacitor on an AC source. And when we're looking at it like this, it does appear like the AC current is flowing through the capacitor. That is the effect. But however, what is really happening is this. The capacitor's plates are being charged and discharged alternately by the alternating current. I hope this demonstration clears up some questions about capacitors being able to block DC and capacitors being able to pass AC current. Thanks for watching.